Today we're going to be making a foldable on center, shape, and spread. And some of it is going to put together information that we had, and then we're going to talk a little bit more about shape. We mentioned it some yesterday, but we're going to talk a little bit more in depth about it today. So follow along, pause when you need to, and have fun. All right, here we're going to be talking about measures of center. And there are three measures of center that we've already talked about: median, mode, and mean. So the first thing we're going to do is we're going to calculate the median of a data set. The median of a data set by, we're going to order the data in ascending order. Just to refresh you, ascending means least to greatest. It means going up. So we're going to find the middle number, which if we have a middle number, that means we have an odd amount, or the average of the two middle numbers, which means we have an even number set. So we're going to use this information right here, right there, to find the median. So the first thing I do is put it in order from least to greatest. And you know what I'm going to do? I am going to count first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is an even set, so we need to find the average of the two. All right, so I have paused it, and I've put them in order from least to greatest, and I double checked them, and I do have 12. So I know that half of 12 is 6. So I know I'm going to come in 1, I'm going to come in 6 on each side. 2, 3, 4, 5, 6. Here's my middle. Well, they're both 29. So what that means is I don't have to average it. 29 plus 29 divided by 2 would be 29. So my median is 29. So I wrote that here. And I also want to come over here on the side, and I want to put that keyword. Median also means middle. It is that middle number. All right, so next we're going to go to mode. All right, so with mode, we're finding the most, oops, my pen went away, there we go, the most repeated number. There can be more than one, or there can be no mode, which we would write the word none. Do not write 0. So if I look at my data set, I can see that 23 is repeated 3 times. And as I check anything else, I see some that are repeated twice, but nothing else. So our mode is 23. And again, we want to put our little keyword over here. This is the most. So now we're going to calculate the mean of a data set. And what it is when we add it up and we divide that sum. So we're going to divide that sum by the number of values that you added. So our keyword for mean is average. All right, so our keyword again is average. And so what we're going to have to do is add up all these numbers, or where we put them in order. I'm going to save you a little bit of time. Thank you, Miss Swindell. And I'm going to tell you that the sum of them is 354. I'm going to divide that by the number of pieces of data we are, which is 12. So when I do that, I can't get any there. I can only get 2 here. That'll be 24. 1 and 1. My 4 comes down. Right, it can go in there 9 times. Oops, I keep losing my pen. 9 times, which would be 108. And when we subtract that, we have a 6. So we'll need to go ahead and put that decimal and that's 0. We need to take care of our remainders. There is no r, and be 5. So our mean, the average of all that piece of information, is 29.5. So first, again, we're going to add them, then we're going to divide. All right? So hopefully that's all a review, but it puts it on one page for you. All right, so here we're going to talk about shape. So we're first going to draw a picture, and then we're going to explain the meaning. This first one that we're doing is uniform distribution. I'm going to pause it, draw the picture, and then I want you to copy what I've done. All right, so in this first one, we have uniform distribution. It means the same, evenly distributed data. So what I want you to do is to draw a line this way. That is evenly distributed. There's no peak, there's no valleys, it's uniform. The next one we're going to be talking about is a skewed left distribution. So again, I'm going to pause and draw a picture and write the meaning, and then we're going to talk about it. All right, so in a skewed left distribution, we want to make sure we have that word left. The tail is to the left, which is that way. So if we were to outline this graph, it would be like this. And so this right here is considered the tail. Okay, do you see how it's long, kind of like a kite? Like this is a kite, and this is going over the data. Okay, well, in a skewed right, it's going to be opposite. All right, so in a skewed right, the tail is to the right, which means most of my data is on the left, and my tail is going that way. So, and by the way, I should have mentioned this. I'm not actually counting the points. I'm just trying to get the shape. So our last one to talk about is a symmetrical distribution, which we had one of those yesterday, and we talked just a smidgen about it. All right, so in the symmetrical, the mean is equal to the median. It's the same amount on both sides. If we were to draw this, it would look like this. So this isn't a key thing here. The mean equals the median, and it's the same on both sides. On this page, we're going to be talking about the spread. The spread of the data can also be referred to as the range. And so we can find the spread on a stem leaf plot by, we can find it by the difference subtracting between the largest and the smallest data points. We can find the spread on a dot plot by, again, using the difference between the largest and the smallest data points. So, on the box plot, what do you think it's going to be? I wonder. All right, you got it. The difference, which means subtraction, between the largest and the data points. But the histogram will be just a little bit different. Will it? Possibly. Hang on just a sec. We're just going to phrase it a little bit different. The difference between the largest and the smallest in the intervals. So think back to when we did that one in class with the time. Our time started like at 9 o'clock in the morning, and let's say it ended at 5 o'clock. We might not have data at 5 o'clock. It might be like 4:58, but remember the histograms is grouping. So we're going to take the largest of the grouping and the smallest of the grouping and subtract it. So it's going to be a little bit more generalized. So here we have my favorite one to say interquartile range. So let's get the formula down. All right, the formula is the median, the Q3 minus the Q1 will give us the IQR. So in the box plot, we're going to go ahead and put down here that it is the difference between the Q3 and the Q1. So think about when we spread our hand out, it's that ring finger and the pointer finger, the difference between those two. So I'm going to quickly draw a little box plot here for a second. All right, so I just want to kind of remind you of what it is. This Q2 is the median of this number set. So if we were doing that, this would be the pinky, this is the ring finger, this is the middle finger, this is the pointer finger, and this is the thumb. You remember how we spread it all out to get our spread or range? Well, the interquartile is the difference between the pointer finger and the ring finger. We need to add one more definition here, the outlier. So the outlier is a data value much smaller or much greater than the median, and the general rule of thumb is 1.5 times greater, or 1.5 times smaller. All right, you do have some work to do with this. Don't lose this piece of paper. This is the one thing that we would probably let you use on a quiz. Hint, 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 that you might possibly have next week. Hint, hint, hint. This is what you get to use. So pay attention and make sure you don't lose this. Put it in your interactive notebook. Great job, kids. Bye.